Hello, everybody. How are you doing? It's Mourad Sultan Ezouidi again with you. Okay. Today we are going to solve a third degree polynomial equation using my method. And after that, we are going to see that the method of Cardan is not available for any polynomial, for any third degree polynomial equation. Okay. I mean that there is an error while using, let's say, the method of Cardan. Okay. Cardon itself told that we can solve polynomial to the power 3 using his method, okay? But his method, in fact, doesn't work for some polynomial equation, okay? Just now focusing on this method, after practicing and training yourself, we're going to give you the Canteri example that will retail the method of Cardon, okay? Let's start, learners. First of all, I'm going to tell you that prepare yourself, prepare your scientific calculator. Those who are interested in seeing how we solve a third degree equation, okay, using a new method of mine, of course, okay, and prepare also some papers, and we are going to work together, okay, through this lecture, okay. So, learners, I'm going to share my screen so that every one of you can see my screen, okay, and work at the same time. Your mathematical professor, teacher, Tunisian teacher, Mourad Sultan Ezouidi. Okay, now we start. Okay, I'm going now to share the file with you, learners. Okay, here we have three examples, three third degree polynomial equation we are going to solve. Okay, I will go to example number 3 first, then we have 4, then we have 5. This is 5, okay. Let's go. So it's a new method, learners. You can learn from me, okay, and apply the discriminant formula of Mourad Sultan Ezouidi so that you will get your new third degree polynomial equation. After that, you are going to find the x roots of this third new polynomial equation, okay, and at the end you are going to find your exact roots, okay, with no estimation, learners, okay. So we start, may we reach example number 3, this one, yes. So learners, I'm going to hide this there on the top, okay. I will try to make the lesson for you clear, okay. Okay, so this is our polynomial, okay, equation that we are going to find its exact roots, learners. This is p of x equal x raised to the power 3 minus x squared plus 0.375x minus 0.0624 equals 0. Okay, I'm going to write my polynomial equation as that p of x equal x cubed minus L0 of ODQ x squared. Here L0 of ODQ, learners, is 1 plus L1 of ODQ x raised to the power 1. L1 of ODQ, learns, here it will be equal to 0.375 minus L2 of ODQ. L2, learns, is 0.0624. Okay, 24. Okay. So here, learners, we are going to solve this question. Okay, this third degree polynomial equation. I'll give you time, learners, to start. Okay, I'll just write something here. Okay, this is 25. Okay, now, learners, we have, let's focus on the third degree polynomial equation above. To find its roots, learners, we should determine the values of SR for the Q relative to LR of all the Q. Means here, learners, you are going to find exactly a new third degree polynomial equation, okay, by finding S minus 1, and S0 and S2. After that, you are going to conclude your X roots, okay? Here, learners, we told that L0 of ODQ is 1, L1 is 0.375, and L2 of ODQ is 0.065. Now, learners, we are going to use the discriminant formula of me so that you can find the coefficient of your new third degree polynomial equation. I'll check my mobile first, okay? Okay. Hello, Ahmed. How are you doing? I'm live now, okay? I'm live, okay? So we continue. We thought that I'm going to use my discriminant formula, learners. This discriminant formula, it's a formula that had been generalized for any nth polynomial equation. Through this or by this discriminant formula, you can find the coefficient of your new nth degree polynomial equation. Therefore, I'm going now to set k equals 1 in the discriminant formula of me. We'll obtain the following learners. Okay, we have a 0 of order r equal negative combination 3 choose 1 times 1 because a 0 of order q is 1 plus 3 times 1 because of course a 0 for the q is 1. So negative 3 plus 3 equals 0. This one has been derived from this. Okay, when putting k equals 0 in my discriminant formula, you will get this formula, n minus n times a0 for the q. We told a0 for the q for any nth degree polynomial equation is always equal to 0. Okay, we continue. We want to find S1. Okay, here to find the S1, learners, just put k equal to in the discriminant formula of me. The discriminant formula is sk minus 1 of order r equal the sum from 0 to k combination n minus r choose k minus 1. K minus r, sorry, n raised to the power r between parentheses negative 0 of order q raised to the power k minus r times l r minus 1 of order q. Therefore, learners, after distributing or developing or expanding this discriminant formula when k equal 2, we'll obtain S1 equal, this is S1 equal negative combination 1 choose 1 times combination n choose 2 times L0 for the q squared plus n squared times L1. This formula is generalized for any nth degree polynomial equation. Okay, now learners, I'm going to calculate. We have S1 of order r equal negative 3 because 3 choose 2 is 3 times 1 because I0 of order q is 1 plus 9 squared, 3 squared is 9 times L1. This one equals 0.375. I'm going to use my calculator so that you can at least understand how we calculate this. Okay, this is the calculator, learners. We told learners, I'm going to put this here if it is possible. Okay, no problem. Put this there. Okay, like that. Okay, I'm going to calculate this. We have negative 3 times 1 squared is 1 times 1, okay, plus 9 times 0.375. So this one, learners, has to be equal to 375 divided by 1000, which is 0. Or we can write it dot 375. Okay, now we calculate, let's say, S1, learners, we are going to find S2, okay? Putting k equal 3 in my discriminant formula. So after developing and simplifying this expression, we obtain S2 equal 2 times combination n choose 3, L0 for the q raised to the power 3, minus combination n minus 1 choose 1, n squared, L0 for the q raised to the power 1 times L1 plus n cubed times L2. Okay, this formula is generalized for any nth degree polynomial equation, learners. Okay, so but because this S2 will give you the value of S2 for any nth degree polynomial equation. Okay, now learners, we continue. We have L0 is 1, L1 is 375 divided by 1000, and L2 is 625 divided by 10,000. Okay, I'm going to just substitute in the discriminant formula when k equals 3. So I will obtain 2 times 1 minus 9 times 0.375 plus 27 times 0.0625. This one has to be equal. Okay, I will use a calculator. So we told that 3, no, not 3, 2, sorry, 2 times 1 cubed minus 9 times 0.30, 0.375 plus 27 because 3 square, 3 cubed plus 27 times 0 times 0.0625. So this one has to be equal, learners, to 0.300, 3125. Okay. Therefore, learners, thank you, Mr. Mann. Thank you for reacting. Okay. So we continue, Mr. Maher. ZD is an English teacher. It's the best friend, okay, of me, okay, and he has got, let's say, good pronunciation and a good English. Thank you for that. We are here to learn from you, Mr. Maher. We continue. Between parentheses, we told that S2 is equal to 0.3125. Now, learners, we are going to calculate or find or write your new polynomial equation. So the original one is x cubed minus x squared plus 0.375x minus 0.0625. Therefore, I already calculated, let's say, s minus 1 and s1 and s2. Then I can write my new polynomial p of x equal x cubed plus 0.375x minus 0.3125 because this one s2. Okay. Now the x roots, this polynomial, this third polynomial equation has x roots as y subscript k belongs to 0, 1, 2 equal 0, 5. This is the first root. And negative 0.25 plus 0.75 I imaginary. This is a complex number. And this also a complex number minus 0.25 minus 0.75 I, AK. Therefore, you can note that if you are going to add all the x roots of this new third polynomial equation, you will get that is really equal to 0. You can see 0.5 minus 0.25 plus minus 0.25, this is 0. And also we have here 0.75i minus 0.75i also equal to 0. Therefore, the roots of my new third degree equation are in fact 0.5, negative 0.25 plus 0.75i. Then the third root is negative 0.25 minus 0.75i, means that we have a root and two complex numbers. Okay. Now, if we're going to solve your original polynomial, okay, this is the original polynomial that we started with, learners, is that x cubed minus x squared plus 0.375x minus 0.0625. Okay. Now, learners, beta subscript 1 is the first root of my original third degree polynomial equation. The formula will tell you that beta 1 equal 0 for the r plus x1. x1 is the x root of your new third degree polynomial equation that you obtained after using or applying or practicing my discriminant formula. Okay. Therefore, now just substitution, L0 is 1 plus x1 is 0.5. So 1 plus 0.5 divided by 3. It will be 1.5 divided by 3 gives 0.5. Okay. If you want to replace or put 0.5 in your, let's say, in your original polynomial equation, you will get that is already equal to 0. And then beta 2 equal 0 for the r plus x2. x2 is the second x root of your new third degree polynomial equation divided by 3. Just calculation done, substituting. So I will obtain 0.25 plus 0.25i because imaginary, because it's complex number. And for beta 3, the third root has to be equal to L0 for the r plus x3 divided by 3 equal 1 minus 0.25 minus 0.75i all divided by 3. You can simplify more. You will obtain negative 0.25 minus 0.25i. If you are going learners to add these three roots minus, okay, this is, of course, this is my plus positive, sorry, 0.25 plus 0.5 plus 0.5 will give you the 1, and the rest has to be equal to 0 because plus 0.25i minus 0.25i is equal to 0. These are the roots of your original third degree polynomial equation. Look here, learners, there is a strategy. Till now, you are still in level A, okay? And now we are going to jump, means we are going to see new method, okay? Using or new method by extending your original third degree polynomial equation to get a fourth degree polynomial equation. Means you are going to extend it, means multiply your original third degree polynomial equation by x to obtain your fourth degree polynomial equation. Look here, we are going to focus on this method because it's very, very important. Okay, this is my original polynomial equation. I just extend your original third degree, of course, Mr. Murad, fourth degree polynomial equation, original polynomial equation, to obtain a fourth degree polynomial equation. It has to be written as that x raised to the power 4 minus x cubed plus 0.375 x squared minus 0.0625 x equals 0. Therefore, learners, I'm going to calculate S1, S2, and S3. Okay? I will, of course, you are going to use the discriminant formula of Mr. Mourad Sultan Ezouidi so that you can find out the values of sk minus 1 about Look, learners, if you are going to use calculator, you have S1 of order R equal negative 6 times 1 squared plus 16 times 0.375. This has to be equal to 0. S2 of order R equal 8 times 1 cubed minus 32 times 1 times 0.375 plus 64 times 0.0625. This one also learned has to be equal to 0. Okay? And S3 is equal to a 3 times 1 squared raised to the power 4 plus 16 1 squared plus times 0.375 minus 64 times 1 times 0.0625 plus 256 times 0. Why? Because the last term here, L3 is equal to 0. We can add here plus 0. So that it's clear for you. Okay, this one has to be equal to negative 1. Means here I'm going to use the unit circle. Okay, means I will try to find two different numbers which that will be real numbers, and I'm going also at the same time find two imaginary numbers or two complex numbers, okay, if it is possible to clarify this. Therefore, my original polynomial learners has to be equal to that p of x equal x raised to the power 4 plus s3 of order r equal 0. Why? Simply because s1 and s2 are equal to 0. Therefore, I'm going to focus on the last on the last value of s3 of order r. Therefore, we can write, you see s3 of order r, I will transfer on the right hand side, so it will carry with that negative sign. Therefore, x4 equal negative s3, or s3 is what? Is negative 1. Therefore, x raised to the power 4 equal exponential 2k I pi. As here this x has been raised to the power 4, I'm going to find x, means I are going to raise this to the power 1 over 4, okay? Or just divide the exponent by 4. Therefore, xk belongs from 0 to 1 to 1, 3 is equal to exponential 2k I pi over 4. I will simplify by 2 on above and on the denominator, so that this will be equal to exponential k I pi over 2. Okay, k of course belonging to 0, 1, 2, and 3. If we are going now, learners, to find the x roots of your new fourth degree equation, just here replace k with 0 and k with 1, and k with 2, and k with 3. Okay? Now learners are the roots of your original third degree polynomial has to be equal to that L0 of O dq plus xk. Xk denotes the x roots of this fourth degree polynomial equation. Okay? We use the x roots for your new nth degree polynomial equation to find the roots for your original nth degree polynomial equation. You see the difference? Very important. Therefore, L0 learns is 1 plus exponential ki pi over 2 divide by 4, of course. Now I'm going to distribute or to set k equal 0, then set k equal 1, then set k equal 2, then set k equal 3 to find my fourth x roots of my new fourth degree polynomial equation. Therefore, when k equal 0 learners, so this one, okay, from where we got, yes, this one learners has to be equal to, okay, beta we told, or I'm going to find x, okay. So 1 over 4 is 0.25, okay, plus what? Plus exponential ki pi over, over, over 4, okay. I'm going to write something here, where x, I will just write this one, are equal respectively to the first one when k equals 0, it will be 1. Then when k equal 1, it will be exponential I pi over 2, it will be I, positive I. I'll make positive I, it's better. Small I, Mr. Mourad. Okay. Then when k equal 2, it will be minus 1. And when k equal 3, it will be negative I. Therefore, these are the fourth x roots of your new fourth degree equation. Okay? And there is a relationship between this fourth degree polynomial equation to the new third polynomial equation. Okay, that we wrote it above. Okay. Now, learners, I'm going to focus on the relationship between a polynomial raised to the power 4 and a polynomial raised to the power 3. Look here. This is very important, learners. There is a relationship between the x roots for a k and a k degree polynomial equation and for another k minus 1 degree polynomial equation. This is the relationship between, like a formula, okay, between these two polynomial. Now, learners, I'm going to focus. I'm looking for yk from 1 to 2, okay, because this one is called the x roots of your new third degree equation, okay, before extending the power of this polynomial equation. So therefore, the formula tells you that yk equal minus L0 for the q, which is minus 1, plus 3 times xk. The xk is that, learners, okay, this is xk, okay, or just replace with 1, then with positive I, then with negative R1, then with negative minus 1 to obtain your 3 x roots of your new third degree polynomial equation. Therefore, xk learns yk equal, just we simplify this one, yk, it will be what? Negative L0 for the q divided by 4, ik, means negative 0.25, ik, plus 3 divided by 4 is 0.75 times exponential ki pi over 2. Now just replace, learners, we'll obtain the x roots of your new third degree equation, this one, okay, means this, you will obtain 0.5, then negative 0.25 plus 0.75i minus 0.25 minus 0.75i. Okay, now we solve this equation. Learners, why I'm going to give you this method, because I'm preparing you to demonstrate for you that the method of Cardan can't be applied for all the nth degree polynomial equations. The nth degree, n here means the third degree equation, okay? Because in contrary, there is an example that method of Cardan is not available for such third degree polynomial equation, and I will show this for you, okay? If you want to now explain this using the method of Cardan, I will explain this for you, okay? After that, I will give you the contrary example for his method. Okay. Now learners, just here I'm going to write this one, if it is better. Okay, which one? I will use this one. Okay. Now I'm going learners to show, to tell you, okay, I will do it here in front of you. Okay. Then I will erase it. Okay. Then learners, I'm going to, if it is possible, I will try to, okay, I will use this one. Control C. Okay. This one, it's called, I will make delta equal. I will try to use delta operator. Where is delta? I need delta. I will tell you the secret of Cardan method. Okay, so learners can. Where is delta? I'm looking for it. Yes, this is delta. Delta, give it right, is equal to. I will make. Okay, what is the equation? Okay, equal what, learners? Equal S2. I will use this one. Okay, equal S2 squared. S2 squared. S2 of order Q, of course. This is S. Ik. S squared minus. Okay, minus 4 times negative S1 of order Q divided by 3 all cubed. Okay, this is the method. Then I will show you from where we derive this method. Okay, meaning that we aren't, let's say, make something randomly, or we work at random. We gave this formula now. Okay, I will tell you from where we obtain this. Not to give x cubed plus y cubed equal z cubed, then we make a relationship between x plus y all cubed equal z cubed minus 3x x plus y. Okay, means we will never use the identity as Cardan method use. Okay, therefore learners, I will just write here. Okay, divided by what? Divided by 3. I will erase this one. This is 1. Divided by 3. I will show the method. Then I will give you a contrary example to tell that this method can't be applied for some third degree equation. Okay, this is done as S1. This is divided by 3. And this one has to be raised to the power of 3. This is the formula. Copy. Okay. This is 3, we told. This one is that. Okay, this is parentheses. Okay, knowing that uv or xy equal minus. Okay, this is minus. Okay, so this is the method. Okay, now I'm going to calculate this, learners. This one has to be equal. I'll just substitute, if you would like, the value of this equal. So S2 is what? S2 is 0. Where is S2? Where is this one? S2 is 0.3125. Okay, I'll just replace this with 3,125 S squared, of course. I'll make 3,125 minus 4 times negative 0.375. I will write it here. Now I'm going to change this. Total negative what? Negative 0.375 raised to the power 3. I will use my calculator. Okay, this is the calculator. Okay, so this one I'm going to write 0 here, 0 of course, 0.3125 squared. Okay, so it will be 0.3125 squared minus 4 times a negative number, so it will be positive 4 times 1.25 raised to the power 3, because 0.375 divided by 3 will give you 0. Will give you 0.125. Okay, raise it to the power what? Raise it to the power 3. Okay, this one is equal to what, learners? Equal to 0. I will use also my calculator. So we have 0.3125 squared minus 4 times between parentheses negative 0.327 divided by 3 raised to the power 3. So this one equal negative, okay, 105, 469. Yes, approximately. This is, you can round this. Okay. So this one, learners, I will now find the roots. Okay. So this is delta. It's positive. Therefore, I'm going to find, I will make to the power what? To the power 0.5. I'm going to find the roots of this. The root of this will be 0.5. Okay. Equal. Okay. Approximately, I will use, okay, to the power 0.5. So it will be 0.32. I will stop at 60. Okay, 0.32, 4760. Okay, I will stop at here. Okay, plus what, learners? Plus now, plus we told 0.0625 plus 0.0625 equal, then divide by 2. Okay, this one I'm going to make to the power 1 over 3, to the power 1 divided by 3. Okay, then I'm going to write the answer. This one has to be equal approximately. I will write this one here. Okay, 0. Okay, it will be plus 0.0625 divided by 2 raised to the power 1 over 3, 0.68. Okay, so this is for x. Okay, I will make it here. Okay, copy. Now plus what, learners? Between parentheses. Okay, plus we told plus, okay, this square minus plus between parentheses. Okay, plus, can I use the calculator? Okay, plus between parentheses we told, okay, we told 0.35 squared. First of all, I will make 3,125. Okay, plus Mr. Mourad between parentheses, there's another parenthesis. It will be 0.3125 squared plus 4 times 0.125 raised to the power 3. Okay, and then this one has to be divided by 2. Then I will close the parentheses. Then raised to the power third, 1 over 3. Okay. I'll see. If not, I'm going to do it separately. So now it doesn't work this one. I'll make separate learns, okay? So the method, I'll continue here. Therefore, x cubed, I will write here x cubed if it is possible. So no. Okay, this is x cubed raised to the power 3 has to be equal to learners, we told s2. Okay, s2, I will make here a fraction. Okay, s2 we told plus, of course I divide by 2, plus what? Plus root of delta, plus root of delta. Delta is that divided by 2. This is x cubed. Okay, now y cubed is that. This is y cubed now, learners, is equal s2 for the cube minus delta. Okay, now I'm going to work out the value of delta, learners. Okay, therefore, after finding y cubed and x cubed, just find the cube root of this one. Means now, learners, I will use this one. Okay, minus x is equal to, of course, cube root. I will make power. Okay, 1 divided by 3. 1 divided by 3, and this one is that. Okay, of course, between parentheses here. Okay, this is for the value of x. And y learns is that. I'll just make minus. Therefore, Mr. Mourad, or this implies that y equal, okay, minus. So this method of Cardon, he used this method, okay? Okay, now learners, look how he do this. For example, here, learners, if x cubed equal the value means x equal this, or I'll just write this one also. Or I will write here, okay, or x equal, I'll make also like that. Then I will go to y. No. Y divided by 3. Okay. Or x equal s2 for the cube plus root of the divided by 2 exponential what? 2k divided by 3. Okay, when k equal learners 0, we'll obtain this. When k equal 1, it will be exponential 2i pi divided by 3. Okay, I'll make exponential if it is possible. Exponential 2i pi, I'll make fraction 2i pi divided by 3. We told when k equals 0, I'll obtain this. When k equals 1, I'll obtain 2i pi over 3 times this one. Now, learns when k equals 2, I will write it here. It will be 4. 4i pi over 2. But for I pi over 2, I can write it what learns? I can write here minus, and here it will be I pi over 2. This is learns for the roots of x cubed here. Now I will find now the for the next y cubed equal s2 minus the root of this divided by 2. Okay, I'll just replace this okay here. So now learns also y can be equal to, we told, okay, erase this. Right. We told that, I'll make it here. I'll show a secret here, learners. Okay, and I'm going to take this only. Okay, I need it. So this one we told S2, okay, minus root of delta divided by 2 raised to the power 1/3 times what, learners? Times exponential times exponential I pi, 2 I pi, of course, here, 2 I pi. When k equal 0, I obtain this. When k equal 1, I'll obtain this. When k equal 4, I will obtain minus exponential I pi. Okay? Therefore, learners, you see, look how to solve this kind of question. Now the x, if we suppose that here, learners, suppose that z, for example, z equal x plus y, okay? Therefore, the roots of z is the sum of x plus y. I will just make x plus y, the first value is x plus y, means s2 of the cube plus root of the divided by 2 raised to the power third plus s2 of the cube minus root of delta divided by 2 raised to the power third. This is x plus y. And the next roots, it will be, you make cross multiplying. Okay, this is to make the cross multiplying. I will show you this for you, techniques, so that we'll never forget this method. Okay, x multiplying, we make like that. Okay, you will make x, and this one will be like that. Insert. Comes, please. Here. Okay, and this one here means that you'll make what exactly, learners? We'll make s2 plus root of delta divided by 2 x raised to the power third times minus exponential I pi over 3 plus, then I will make s2 of all the cube minus root of delta divided by 2 multiply by I pi over 2 I pi over 3. Okay, means you multiply the first term, this one, by minus exponential I pi over 3. I will just do this like that. Therefore, I will write z equal zk or whatsoever equal, I will make this one. Okay. We told I will multiply by minus exponential. I will make here minus exponential. I will now reduce the 2. I will exclude this 2. Then plus what? Plus this. But here I'm going to multiply by the exponent. I will multiply by 2, means, okay, this is 2 I pi. This is the second root. So this is the second root. Okay. We use cross multiplying to find the second root. Okay. And the second one will be like that, learners. We reverse it. Means I will use this multiply by, means s2 of all the cube plus root of divided by 2 multiply by exponential 2 I pi. So I'll just replace, this is minus, this is no need. Okay, okay. We told I will multiply this by x 2I pi, 2I pi, 2I pi, okay. Plus what learns? Plus, we told, okay, this is, it will be plus, then it will be minus, here minus, or I will make 4I pi, I will change by 4I pi, it will give me minus exponential I pi. I will make here minus exponential I pi. Okay, this is the solution. Okay, uh, now learners, look, we continue. I will just, if you use this formula, you will obtain the same roots of this. Okay, so thank you for listening and see you inshallah next time. Okay, I will save this one. By the time learners, by the time, okay, I will try to close this. It is possible. Okay, stop sharing. This is no need now. Okay, learners, we finished the example like that. This rate for you is not available for some third degree polynomial equation. How can you now behave with a degree polynomial equation? Okay, and you learn